There we go. All right. What's that? I have what I handed out last time, and I forgot to bring it with me. Unfortunately, I really can't. However, I did post it in course content, so like, there's a copy there. If you follow me back to my office afterwards, I got more down there. I just didn't bring it with me. I will also say, they don't. This is relevant to test 2, right? Like test 1 is still on. It's more on, the material which was covered by quiz 1 also, right? Okay, so we already solved a bunch of these already. So let you guys. I'm going to give you guys a couple minutes. You should try to do numbers 6, 7, and 8. All right, you guys try to do number 6, and I'll write it up here. So basically, you want to solve this 2x plus 4y equals minus 2, and 2x minus y equals to 6. I'm going to ignore the instructions. You can do substitution or elimination, whatever method you prefer. Just try to solve that system using one of the techniques that we talked about. Exercise 7, solve system. Here we've got 4y plus 2x equals to 20. And we've got minus 8y plus 3x equals to minus 26. Get back up there. Exercise 8. X plus 30y. So you should be trying to solve these while I'm writing this up here. You do not need to phone a friend. Let's see here. 5y equals to 1. like add y to both sides and subtract 6. Let's see here. So like which is the right method, like substitution or elimination? Substitution is a good method if in the equations we're looking at, we just have like the variable sitting, one of the variables sitting by itself without a number, right? So maybe substitution is a good method for exercise 6 because we've just got y sitting here. It's pretty easy to solve for y, right? What's that? Yeah, basically. Solve for y and then plug it into the first equation. That's what we want to do for number 6. You do what? Oh, yes. So that's a good question. Am I still going out of town Thursday? So let's talk about my weekend. So Friday I was minding my own business, trying to get my work done, and then my realtor texted me, "Congratulations on your closing today." I don't know. Do you guys know what closing means? Like when you sell a house, you guys So well, that's good news if you're planning on a closing that day. But when you're planning on the closing being this Friday, that's upcoming, hasn't happened yet, that means that someone has dropped the ball. So, is it the realtor? Is it the closing company? I don't know. The blame could go either way. They're definitely both involved. Anyway, long story short, we drove to Virginia this weekend and closed on Monday. So I've already done that, and I'll be here Thursday, Friday most likely. So sorry to disappoint. Although, I will add, the other section of intermediate algebra, for some reason thought that just because I didn't come to class yesterday, that means they didn't have to take the test. Like, I do not understand this logic. Don't do this. Like,
you just skip Thursday when you take this.
Like, you come and take the test when it's offered. Like, I might let you take it later because I'm trying to be nice, but there are many, many professors here who would be completely within their rights to tell you to, no, this is college. You miss a test, that's on you, right? So you're playing a most dangerous game when you skip a test like that without reason. Anyway, this is, of course, a talk I should be giving them, not you, because you guys aren't going to do that. Partly because I'm here, but partly because you won't do that. I'm having a much easier time focusing in class today for some reason. We're missing some distraction. That's right. I hope you'll watch the video. And did you?
I got my homework to work now.
You get your homework to work now?
Yeah.
Well, hooray.
Today?
Well,
Did you do it yet?
it's good. La 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 la. I didn't hear any of that. I'm not going to hear anything about the not having done homework at this point in the semester.
Well, I told you it would never work. You tell Mom. Oh. You tell me about it.
But
Have you done it?
I am not listening to this.
Raise your hand if you've done homework. Wow. I guess I really don't understand.
But I did hope you were able to look at those PDFs before the system was working, you know. Okay, so let me work these problems now that you guys have had a chance to work them, and some of you have. So I think the smart thing to do here is to solve this for y. This gives me, we had a breakthrough last class. If I do this, then everyone will understand. And then I will subtract 6. And that will give me 2x minus 6 equals to y. For some reason, I cannot do this on paper. Like writing this vertical format on paper, it offends me somehow. I don't know. I tried to write your solution using this format, but I just couldn't bring myself to it. I work horizontal. No. Oh, that was not a, the pencil was not, it was not a comment. It was not a comment. It was not a commentary. It was just a. Okay, so there we go. Is that the solution? Well, that's not the solution yet, right? But we have substituted. That gives us a way to substitute in x for y. So we take this, right, and go back up to the equation that we haven't used, this one, right? And we get 2x plus 4 times 2x minus 6 equals to minus 2, right? And at this point, we have come to a potential test 1 question, right? One equation, one linear equation, and one variable. That's the kind of problem you'll face on, one of the kinds of problems you'll face on test 1. And what do we got? So of course that gives us 10x equals, 10x minus 24 equals minus 2. And then I'll add 24. That gives me 10x equals to 22. X equals 2. 22 over 10, right?
You want to reduce it or just leave it like that?
Sure, reduce it. What'd you get?
11 over 5.
11 over 5. That'd be fine, yeah. Either would be fine with me. But what's, no, okay, so great, there's x. The solution is always a pair if it exists, right? So if that's x, then what's y? Y equals to 2 times 11 over 5, right? Minus 6. So that's equal to 22 minus 30 over 5, which is minus 8, minus 8 fifths. So solution is actually 11 fifths minus 8 fifths. There's the solution.
I understand. No, I actually understand.
That's good. This is actually one of the problems in the homework, so that will help you since you haven't done it yet, right? Yeah. Let's see here. Now, the next one, you know, I don't think solving for y or for x is wise. What I'm going to do is I'm going to take the first equation and I'm going to multiply it by 2. All right, I'm going to take the first equation, multiply it by 2, and write it under the second one, because then I can add them, right? Multiply by 2. What happens when you multiply by 2? You get what? You get 8y, excuse me, plus 4x equals to 40, right? Yeah, then the 8y's will cancel, right? Then we'll add these equations. And that gives us 7x equals to, looks like 14, yeah? 40 minus 26 is 14. So x equals to what? I heard a 2, right? 14 over 7, which is 2. Now we still need to find y. How should we find y?
Plug the 2 back into the top.
Plug the 2 back up into the top.
The x at the top.
Oh, okay, and so you want to use the first equation, so we've got 4y plus 2 times 2 equals to 20. So y, yeah, 4y equals to 16. Y, and I heard y equals to 16 over 4, which you told me is 4, right? So solution is an ordered pair, right? And that ordered pair is 2, comma 4. So the training started early.
Yes, sir.
So we'll have this video so you can watch later today. Email me if you got any questions. All right?
Sorry.
No, it's okay. It's okay. No problem. Whatever you guys are missing, I don't. I assume there's just probably a reason for it, and I just hope you watch the video when you get a chance, because I don't want you to fall behind. Any questions about this one? I mean, there's something else we can do that we haven't done yet, which is to check our answer, right? No? We just leave it? You don't want to check the answer? I'm going to check my answer. You can't stop me. I'm going to check my answer. So,
You got it right. I checked it for you. Jason's been going to a tutor, so he might as well be, what's his name? A genius. But Albert Einstein, that's his name. What the? How's that?
this one's funny, right? They have the y's written first and the x's written second, don't they? So, right there below the alleged solution, what I did was I plugged the numbers back into the equations and saw that they actually did reproduce 20 and minus 26 like we'd like, which goes to show you we did it right? The solutions check. You'll definitely have enough time on the test to check your solutions, right? Now I'm talking about test 2, but it's true for test 1 as well, right? You can check your solutions for one equation, one unknown, just the same. All right, exercise 8. How are we going to do that one? Oh, you got it? Oh, cool. I think, again, like we don't want to solve for like elimination. Excuse me. Substitution's not the right method, right? We want to use elimination, try to add and subtract equations. And we need to make them match up. What do you think we should do? What do you think? Multiply the bottom one by 6? You guys agree? Great. All right, good. So that multiplied by 6 gives me in other words, we get 24x plus 30y equals to 6, right? And I'm going to copy down the first equation again, which was 3x plus 30y equals to 7, right? I can't fit a word in there. So all I did was like this is I've gotten away from using numbering. I should go back to that. And this is number 1. This is number 2. This is 6 times number 2, right? So here we're looking at 6 times number 2, and this is equation 1 again, And the reason they multiplied by 6 was to make the y coefficients match up, right? And now we can subtract. And that gives me what? It gives me 21x, 30y cancels 30y, equals 6 minus 7, which is minus 1. So apparently x equals to negative 1 over 21, right? And now we need to find y. What's y equal to? I think I'm going to use equation 2 because it's got a smaller number next to y. What do you think? Do you agree, Trinity? You agree? Okay. Wait a minute. Something's different about you. What's that? You're bald now. Is it his influence? Are you his disciple? I mean, you just like it? Felt like it? Hey, that's a good reason. Sometimes I feel like it too. You want me to shave my head? What's in it for me? I mean, besides not needing to comb my hair, not that I really do anyway, but it'd be cool. Like literally cool or figuratively cool? Both. Oh. Get a mullet. He wants me to. So I've got one vote for bald and the other vote for mullet. Just keep it the way it is. Well, that's the easiest to do at the moment. But
Do a backwards mullet.
a backwards mullet.
Yeah, instead of shaving the sides.
Party in the front, business in the back. I mean, what's that? Okay.
No, business in the front, party in the back.
But that's a mullet, right? No.
Yeah, backwards mullet would be party in the front, business.
I feel like this conversation isn't going to particularly help you with the next test. I probably should go on. Let's see here. So,
That's a great idea.
2. You guys got to give me let's see here. 5y is 1 minus 4x. Can you agree? Let me say that 2 tells me that, right? 2 tells me that 5y is equal to 1 minus 4x. Did you guys agree? If I subtract 4x to the other side. So and then the reason I'm doing that is then I can say, okay, well that's equal to 1 minus 4 times minus 1 over 21, right? Because x is equal to minus 1 over 21. All right, Kennedy's back on board now. That's good. And so what you're looking at here is 21 plus 4 over 21, also known as 25 over 21. And then if we divide both sides by 5, we get y is equal to 1/5 of 25 over 21, also known as 5 over 21. So my solution is minus 1 over 21, and then 5 over 21. My voice keeps trying to flake out on me today. Excuse me. You could just plug in y. Once you find that x, you can pick either of the equations. You just plug it in and then solve for y. It's the same. Like, you don't have to do it like this. This is just like occurred to me at the moment. Now, exercise 15, the word problem. I say, suppose Thanos pilots a plane. Now, you might wonder why Thanos would pilot a plane. Seems like he'd just fly. Pilots a plane 240 miles against a headwind for 2 hours. And that flight would take 1 hour and 12 minutes with a tailwind of the same speed. Find the headwind and the speed of the plane in still air. So it seems like there are two things we don't know in this, right? The speed of the plane and the speed of the headwind, right? So let me call those speed of the plane, I'll just call VP, like the velocity of the plane. And the headwind, I'm going to call VH, H for headwind. You could, but I'll do V sub H and V sub P. And so the point is that, so the basic thing we need to know about is distance is equal to the speed times the time elapsed, right? Do you guys know this? D is equal to VT. Distance. Speed, yeah, rate times time also is another way to say it. Distance is speed times time. So the distance that the plane travels, right? Now, are we told that? Oh, yeah. Let's see here. So that's 240 miles. And let's see here. on the one hand, it's equal to, so it's going to be the velocity of the plane in still air plus the headwind. Oh, against the headwind. So do we add or subtract? We subtract. So it's going to be, so minus the velocity of headwind. So that times, and then, so we've got to make a decision here, guys. We can either work in hours or in minutes. Right? Then you're going to get like miles per minute as your answer. You're content with that? I mean, that's fine. You say work in minutes? Fine, we can do that. So if we're going to work in minutes, that 2 hours is how many minutes? 120 minutes. Right? But then it says the flight would take 1 hour and 12 minutes with a tailwind of the same speed, right? Yeah, so this is equal to, what is it? 72. Yeah, 72, but that's VP plus VH this time, right? Times 72. So like, well, this is the other idea is if you're flying into wind that's blowing against you and you're on a plane, then your ground speed is like your actual speed relative to the wind itself minus the velocity of the wind. So like hypothetically, if you were flying your plane 100 miles an hour into a wind that was coming 100 miles an hour at you, you'd just be hovering midair. You'd just be basically like treading air, so to speak, If the wind is coming at you 50 miles an hour and you're going 200 miles an hour relative to the wind, then you're going 150 miles an hour relative to the ground. So we encode those ideas with either addition or subtraction as appropriate. So like velocity of the plane in still air minus the velocity of the headwind when it's against us, and then plus the velocity of the headwind when it's with us. In that case, we call it a tailwind, right? If the wind is going the same direction you're going, then the weather, it'll take away time from your flight, right? Yep. Uh-oh. I probably don't. Go ahead.
Yeah, like, if you're on top of a train and you jump,
Uh-huh.
the train's going to go and you're going to be further back on track. But if you jump inside of a train,
Oh, it's because you already have the speed of the train when you jump. So you're jumping up and down in the train frame, but you're actually jumping forward like relative to the ground. When you jump up and down in a train, you've actually, in the train, you just jump up and down, right? In the other frame, you jumped here and you landed over here relative to the ground, So like, yeah, I mean, they're different. It depends on like how far you went, depends on your perspective. From the perspective of the train, you just went up and down a foot. From the perspective of the ground observer, if they could trace where your feet went, yeah, you went a lot farther. It's true. Distance traveled depends on your frame of reference. It is true. What's worse is that they have different ideas of time. Like if you're, no, I may not start into that. No, you see, this is a temptation. This is a temptation. I'm focused. I'm focused. I'm not. I refuse to. Well, I mean, the funny thing is that, like this discussion we just had, it doesn't make sense for light anymore. If you're on a train and if you could imagine being on a train that was going half the speed of light, and you took a flashlight and you shined it forward, that light would not be going 1.5 times the speed of light. It doesn't work that way. It still goes the speed of light. That's what physics says. Like light always goes the speed of light. It doesn't matter if it's from a moving train or it doesn't matter how fast the train is moving. It's still just light. So something. That's it's an axiom in special relativity. Light's fast. But even for velocities, like if you have less than subluminal velocities, the way they add, if they're closer to the speed of light, it's not like the way we're adding these. It's much more complicated. the way it works is such that when you add velocities, you can never have the velocity of your frame of reference plus the velocity of the thing that's going with respect to that frame, such that the velocity with respect to another frame is larger than c. Like the formula is set up so that it has to be less than the speed of light.
That's probably the smartest thing I've ever heard you say.
Yeah, that's just special relativity. All right, so I will attempt to get back to this example now. So guys, why is this word problem in this section? To make sure not. It's to make sure everybody doesn't get an A, right?
Yeah, exactly.
No. It's because it is. It's because this is two equations and two unknowns, right? This is equation 1, and that's equation 2, and you can solve it using our methods. Now, maybe we should change it to x and y just to make the equation easier to think about.
Yeah.
So we've got, let's say, 240. Well, let's say we've got x minus y times 120 equals 240. And we've also got x plus y, 72 rather, times x plus y equals to, 240. How should we solve those? I think I'm going to use substitution. So the first equation is pretty easy to change to x minus y equals to 2, right? 240 divided by 120 is 2. So divide the equation by 120. And then I can solve for y, right? Y is equal to what? X minus 2, that's right. Do you know what a good rule of thumb for whether or not you've done correct algebra is? If you look at an equation and you have two different things in the equation, and one is plus and one is minus, right? If you manipulate that equation such that those things are on opposite sides, they should still have opposite signs. Like as a sort of gut check. I look at this. I've got a minus y, I've got a plus 2, right? Down here, I've got a plus y, I've got a minus 2. So they differ in plus minusness. Yep. I love that she's saying she has a real question, as opposed to the kind that have also been asked today. No, go on. Uh-huh. Oh, I don't know. I just write it down. I don't think about it like that. Yeah, go for it. That's fine. So, I think my internal thought process is to add y to both sides and to subtract 2 from both sides. But at that point, I realize I've put y on the right-hand side and I don't like it. So then I just turn the equation over because I want to write y equals something. So sort of the natural algebra puts y on the right-hand side of the equation, but I don't like that for my answer. So I just turn it over in my head and do that. I don't know if that, that's actually how I think about it. But if you want me to write more steps down, I can. I'm just kind of in the corner of the board is all. I work myself into a corner. And then so we take that, we plug it into the other one, what do we get? An answer? So this, x equals 8 over 3. Let's see here. That sounds plausible. I'll tell you what, I'm going to erase this and work over here because I'm tired of trying to squeeze this down into the corner. And that's a good rule of thumb also. When you're working a problem, make sure you got space to work it. Don't be like me. Don't be a victim of your board space. Poor planning. All right, so where were we? 72, and then we've got x plus y. What was y? X minus 2, right? 240. So that will give me 2x minus 2 equals to 240 divided by 72. That's 10 times 24 divided by 3 times 24. 24's cancel, we get 10/3. And so we get 2x is, oh, wait a minute, I'm losing my chance. I'll write it down again, 2x minus 2 equals to 10/3. I will add vertically. See, I learned. So you're like, that's ridiculous that you're still doing that because you've done much more complicated things without writing them down today. So anyway, but there you go. You don't have to add vertically. If you want to add horizontally, that's fine. But what's 10/3 plus 2? Well, that's 10/3 plus, what's 2? What's that? How many thirds is 2? It's 6/3, right? So that's 2x equals 16 over 3, which says x equals to 8/3, which says to me, you're right. Now, what does that mean, though? 8/3 what? What were the units I was using in this problem, right?
That was the speed of flying.
I know, but in what kind of units? I mean, think about that. So this was in what? This is in miles, right? And this is in minutes, right? So that means that our velocities, our speeds, are actually in miles per minute to make the units work out. So that's 8/3 miles per minute. What if you wanted to write your answer in miles per hour? How would you fix it? You're like, oh, don't do that to me here. This is not that class. How would we convert to miles per hour? Right, 60 minutes, right? Is equal to what?
1 hour.
Yep, 1 hour. So that's our conversion factor. It's just a fancy way of multiplying by 1. So I think essentially you just have to multiply by 60. When you do that, what do you get? What's 60 over 3?
160.
Yeah, 60 over 3 is 20, right? So 8 times 20 is 160. So 160 miles per hour. I'm just putting it back into miles per hour because that gives you a better kind of, sorry about my phone, it's got some indigestion or something.
So you're not going to be at school Thursday and Friday, right?
No, I will be here the rest of the week as far as I know.
When did you email us that?
I didn't. It just happened. Like, I left here Friday and drove to Virginia and then drove back. I have had like very little sleep last night. I have not communicated anything to you guys except what I told you right now. So like last week, I told you I wouldn't be here at the end of the week. That was on the assumption that the realtors can do their job, which is incorrect. So, an important life lesson, by the way. Don't use realtors. I'm sorry, are any of your parents or relatives realtors?
No, my brother and sister-in-law.
You know, I look on Zillow, I find a house I like. It says for sale by owner. I just look at the number, call them up and say, hey, can I look at your house? I go over there and he shows me the house. Simple as that. Like, there doesn't need to be a third person. I mean, anybody else involved?
Oh! I was giving
What?
a shot. The needle broke. Oh my god.
I look over there, it looks like he's about to jab a pen into his arm. Like,
No, I was trying to give him a shot.
This class is more interesting than the rest of my classes this semester combined, easily. That's a compliment. Anyway, so what was y equal to? X minus 2, right?
Negative amount third.
Really?
What?
It's
Oh, I got it.
negative.
I used the 120.
Why?
I used that one.
Oh,
Wait a minute. I think. If I did it wrong.
oh, good, good, good. You had given me some cause for.
Whenever I subtracted over, it
Okay,
was minus 120.
Oh, good, good, good. You had me worried there for a second. So you should get 2/3 for x. I mean for y. 2/3 for y. So y is 2/3 miles per minute, which if we multiply by 60 minutes in 1 hour, we get, what is that, 40? 40 miles per hour. So I think the answer to the original question is the speed. I was wrong. Chris is not a distraction. Chris is a stabilizing force. So what I have learned from this calculation is, number one, don't talk about realtors in the middle of a problem. Sorry about that. Number two, it seems like the speed of the plane in still air is 160 miles per hour, but the headwind or the tailwind was 40 miles an hour. So that's what we've calculated. So sorry I got distracted mid-problem. I hope you see that the setup is pretty simple. We just use distance as rate times time. And then we have to invent some variables. An important step here was inventing names for the things we don't know, right? If I hadn't done that, if I hadn't invented VH and VP, we wouldn't have had a way to do the problem, right?
Correct.
Now, it was really easy for me to do that. Why? No, it's because I've spent most of my adult life working word problems in math, and I have like a master's in physics for what it's worth. So like, I've done a lot of word problems, and I know how this works. But I also know that that is the hardest step, is that creative step of labeling the things you don't know. Like, you have to do that. It's easy to watch me do it. It's much harder to do it for yourself, right? So there's still another problem in the exercise sheet, you know. It's a word problem. I'm going to let you guys work on that. Not right now, though. I think now we should move on to polynomials. So, yeah. We're moving on to polynomials. When did we start? When's class starting here? Started 2, right? I believe we have about 20 minutes left. Plus, actually 20. I said I don't not say we're I did? I thought you were on my side.
We're not gonna lie.
Right,
You
you
said
said
it.
it, and I heard you say it. We all did. Just let us go. I gotta go. And I gotta go to work. I gotta eat.
I gotta go to condition. I gotta go to grab my.
Guys are killing me.
I think you should just
All right, let me introduce the next topic at least. It should take me about 10 minutes. All right, so I believe this is chapter 4 in your textbook. So, of course, the homeworks from section 4.1, 4.2, 4.3, and so forth and so on, these are all about polynomials, all right? So here's what's going to happen. We're first of all going to define what they are. We're going to talk about how to multiply them. and about how to evaluate them as functions. Basically, use them as a formula. And then we're going to spend a while talking about how to factor them. And once we understand how to factor them, then we'll be able to solve what is called a polynomial equation. A polynomial equation is just an equation formed using a polynomial. All right? And that's our ultimate goal in this chapter, is to be able to solve polynomial equations through factoring. All right? So definition, P of x equal to an x to the n plus an minus 1 x to the n minus 1 plus a 2x squared plus a1x plus a0, where a0, a1, an are constants, and a sub n is not equal to 0, is a polynomial of degree n. So the leading, a sub n is the so-called leading coefficient. So the leading coefficient of a polynomial is the one on the biggest power. What can we do with polynomials? We can add them, we can subtract them, we can multiply them by numbers. How does that work? Let me show you some examples. So we could have 3x squared minus 2 times x squared plus x plus 1. How should we multiply these? We use what's called the distributive property. All right? So what I'm going to do is I'm going to do 3x squared times x squared plus x plus 1 minus twice x squared plus x plus 1. And then we distribute through. We've got 3x to the 4th plus 3x cubed plus 3x squared. That's from the first term. And then minus 2x squared minus 2x minus 2. Uh-oh. So, by the way, this is the so-called standard form. Yes. So, in contrast, this is not yet in standard form. Why do I say that? I've got, you said I got a 3x squared and I've got a minus 2x squared. I've not done what? I've not collected. I could collect like terms, right? One of each. Exactly. One of each term is the standard form. We collect like terms. So, like you said, the x squared. Is anything else that collects here? No, it's just those two. Kind of funny, huh? 3x to the 4th plus 3x cubed plus x squared minus 2x minus 2. And there you go. That is in standard form. What we have just shown is, this is a what? This is degree 2. This guy is also what? Degree 2. So the degree is just the whatever n appears in the highest coefficient, like 3 is next to x to the n equals to 2, x squared. So like the exponent's 2 Here are the exponents too.
So it depends on the
Yeah, and this is degree 4.
okay, so we classify it based on the highest exponent.
Right.
Coefficient, right?
Yeah, here's another one, x to the 13th minus 7. This is a kind of easier example to multiply, but this is x to the 5th is a polynomial of degree 5. It's a kind of stupid case. It's just one thing, but it's still a polynomial. Like, that's just when all of these things are 0, except for a sub 5, which is 1. So this is a silly case, just x to the 5th. And then x to the 13th minus 7. All those other coefficients, with the 12, the 11, all the way down to the 3, the 2, the 1, all gone. Just the a sub 0 is minus 7 in this case. So this one, well, I just want to multiply here. So what's 5 plus 13 is what? 18 minus 7x to the 5th. And so my point to you is this one is degree 5. This one is degree 13. What's this degree what? Degree 18. Do you start to see the pattern? What happens if we multiply degree m times degree n? The resulting thing is something of degree m plus n. So like if you multiply a quadratic, n equals 2 is called a quadratic polynomial. So if we multiply n equals 2 times n equals 2, we get n equals 4. Degree 4 is also called a quartic. This is a quartic polynomial. These are quadratic polynomials. We know an awful lot about quadratic polynomials. There's another definition. If you have p of x equals just x to the n, this is called a monomial. It's also called the n power function. Why does this phrase polynomial come from? Like, what does that word mean? Polygon? Why do we call it polygon? Multiple sides, right? Poly means many. Gon means side. I don't know. Polygon. But that's what this is. Nomial. It's many nomials, right? Many terms. So I think that like that essentially means a term. So like many terms. See, well, monomial. This is just one, x to the n. So, all right. So we have one other thing to talk about before we're done today, which is evaluation of a polynomial. So, like, if I talk about, I can think about this as a function. I can think about this as the formula for a function, right? So, for example, if we have p of x equal x to the 4th minus 3x squared plus 2, and I calculate like p of 2, what's that mean? That means we plug 2 in for x and we work it out. So you have a fair amount of homework like this. So you have 2 to the 4th minus 3 times 2 squared plus 2. All right. And then it'll say, and like your homework says something like evaluate the polynomial at this point and simplify your answer, right? So we should simplify the answer. How should we do that? I heard a 16. 12 plus 2, which is what? 16?
That would be 8, not 8,
6, right. So there you go. So, listen, I will make a worksheet where I have some ones for you to multiply out and to evaluate. We'll do some of those. And then also, I'll probably on that same worksheet put some factoring problems. How many of you have actually looked at factoring before in your math? But you're not confident about it, right? Yeah, we need to get really good at that. So so we're going to spend some time on factoring. But anyway, I'm still ending class 10 minutes early, and I feel like I didn't agree to this. I feel like I didn't agree to this. See you guys. Did you stop the video? Did you stop the video?
I don't know how to do it.
Oh, I'll get it.
That's a little silver button right here on the side.
You got it?